The next section of our book is going to be on quadratics. Now, quadratics are graphs that are going to appear U-like. This would be a positive quadratic with a minimum, or it could be upside down. This would be our negative quadratic, and that has a maximum in it. So to see equations that are going to result in a quadratic, they generally follow this form. This can be written as y equals ax squared plus bx plus c, where a is the coefficient always attached to the x squared, b is the coefficient always attached to x, and c is the constant with no variable attached to it. These can be put in any order. However, the a is not always first. It's always the number attached to the squared, same with the b. Okay? And c is always the constant variable that is by itself. So right now, with no other strategy, we can always make a table of this equation to create the graph to prove that this is the way that this equation is going to look. So let's start by making our xy chart. I know a little bit about this equation, so what we're going to do is we're going to go 0, 1, 2, 3, and 4 for our x values, and we're just going to plug these in and start solving. So when I plug in 0 for my x squared, I would have y equals 3 times 0 squared minus 12 times 0 plus 6. Well, this one's easy. This whole chunk cancels out. This piece is also canceled out. So we're left with 0 minus 0 plus 6. Well, that's just going to be 6. So my first point over here is going to be over 0 up 6. So over 0, up 1, 2, 3, 4, 5, 6. Next, I'll plug in 1. So I'm going to have y equals 3 times 1 squared minus 12 times 1 plus 6. When solving quadratics, it's always important to remember your order of operations. Here, we must do the exponent first before we multiply these pieces, and here we must multiply before we do any of the addition subtraction. So 1 squared is 1, 1 times 3 is 3, minus 12 times 1 is 12, plus 6. Well, 3 minus 12 is negative 9, plus 6 gives me a negative 3. So when x is 1, y is going to be negative 3. So x is 1, y is negative 1, 2, 3. Right there. Now I'm going to keep going. I'm going to go through these a little bit quicker. If I plug in a 2 here, I have 2 squared, which is 4, times 3 is 12, minus 12 times 2 is 24, plus 6. 12 minus 24 is negative 12, plus 6 is going to be a negative 6. So 1, 2, 3, 4, 5, 6, and I'm going to go over 2. So over 2, down 6, I'm way down here on my graph. If we continue to plug in our values from our table, we get these as our outcome, and I just want to save some time and graph that for you quickly. So once you have your points, you're going to want to make it into a U-shape, a nice curve at the bottom, and coming back up. Now, one important thing to note about quadratics is that it's always a curve. It's not going to be a V like absolute value, and that the slope that we normally think of with linear patterns, okay, our rise and our run, is going to be different every single time with a quadratic. It's not going to be a constant pattern of increase every time or a constant pattern of decrease like we've seen with linear and like we've seen with absolute value. This piece here is called the vertex. And if you imagine a dotted line here going straight up, that would be our line of symmetry. If we were to fold it in half right here, the distance from this point to here and this point to here, this point to the line and this point to the line are going to be the exact same. And this line is always the x value of your vertex. Again, we can also find our y-intercept. That's going to be another nice hint to graph these quicker. For example, our y-intercept here is 6. If we look over at our equation, we can find that our constant, whatever number is left without a variable next to it, is always going to be our y-intercept. Let's look at a quicker way to graph these without having to do a table every single time. To graph quadratics quicker without having to make a table every single time, there are some shortcuts. And the way that you're going to want to do this is to find these pieces first. Your vertex, obviously, is going to be your minimum or your maximum. Your axis of symmetry, so you know any dot that you do on the left-hand side is also going to be reflected on the right-hand side. Your y-intercept, and then we should also look at domain and range of these functions. So let's start off with our vertex. Now, this is something you're probably going to want to remember. The vertex can always be found by doing negative b over 2a. This is the formula for the vertex of any quadratic that you'll ever have to find. So if we look at this equation right here, remembering that all quadratics are in the form ax squared plus bx plus c, we can take out these pieces, plug them in, and get the x value of our vertex. So, negative b. b is attached to the x, so we're going to take this 4, we're going to make it negative. Over 2, well that's obvious, and then a is whatever's attached to your x squared. Now there's no number here, but it's not a 0, it is a 1. Again, we want to follow our order of operations, so we're going to do this multiplication down here before we do this large division. Okay, we need to do that grouping piece first. So we have negative 4 over 2, which gives us negative 2. That means our vertex, our x value, is going to be negative 2. How would we go about getting our y value? Well, that's easy. We take this negative 2, we plug it in here. So instead of plugging in like 5 different points, we just have to plug in one number, specifically negative 2, to get that vertex. So we're going to take our negative 2, we're going to plug it in. Negative 2 times negative 2 is 4. Plus 4 times negative 2, again, we're plugging in that negative 2 for x, is a negative 8. And then this negative 3 is a constant. So a plus and a minus next to each other are just subtraction. So 4 minus 8 is negative 4, minus 3 is negative 7. So negative 4 minus 3, negative 7. So that means our y value is going to equal negative 7. So if we were to plot this vertex, it's going to be at negative 2 on the x, and then down 7. So here I've gone backwards 2, down 1, 2, 3, 4, 5, 6, 7. Now, my quadratic is either going to open upwards or downwards, okay? Again, we call this a quadratic equation. The shape itself can be called a parabola, okay? So, I kind of use those interchangeably. So if I say parabola and you're thinking quadratic, they are the exact same thing. The quadratic is the type of equation, and the result is a parabola graph. So, we've now done our vertex right here. Now we can determine whether this opens up or down very, very quickly and easily just by looking at our A. If our A is positive, it's opening up. If our A is negative, it is opening downwards. So here I know it's going to be a U shape going upwards. I just need to figure out my first initial points. Okay? Really, for a parabola, you only need 3 points to graph, and at that point you've completed a graph. We can see the general pattern and the spread of that parabola. Our axis of symmetry is pretty obvious. We talked about it briefly in the last video. It's going to be this line right here, which means whatever point over here happens is going to be reflected right over here also to make it equivalent. I'm just going to erase this, and I'll put our coordinate pair here. It was negative 2 and 7, negative 7. Okay, now I have a little more space. So my axis of symmetry, this is a vertical line, so it's going to be at x equals negative 2. This will always happen. They'll always match. X value and the line equation. Next, we're going to do our y-intercept. Again, from our last video, y-intercept is very quick and very easy. It always is your constant. So my y-intercept is going to be y equals negative 3. And of course, the x value there is always 0. So it would be 0, negative 3. Meaning my y-intercept is going to be 1, 2, 3 right here. Now, because of what we know about the axis of symmetry, if we look, this space here is 1, 2 boxes over to our axis. That means we're going to have another point mirrored over here, 1, 2 spaces over. It's going to look like that. Those aren't really part of the graph. Now we can complete our parabola by connecting it with a nice curve. Much quicker and much easier than making a table of all these values. We find our vertex, remembering our axis of symmetry, plot our y-intercept, and then flip that point the same distance from that axis of symmetry onto the other side. Now that we have this equation graphed here, we should talk about domain and range. Now for quadratics or parabolas, every time your domain or all of your lists of possible x values are going to be all reals. And this is because if we think about this, it's going to continue forever heading outwards in both directions for the x, okay? It's going to continue negative infinitely and positive infinitely. Now, our range is usually what's going to be affected by your parabola. It changes every time. Here, because it is a positive parabola, it's opening upwards, we see that we have a minimum. That means this graph will continue upwards forever, but it will never hit any values lower than this. So we need to write this range as an inequality. So we're going to start with y, because the range relates to y values, such that, I know you hate these, but hopefully you remember them. And here, this value on our y-axis is 1, 2, 3, 4, 5, 6, 7, negative 7. So I'm going to say y such that y must be greater than or equal to, because it could equal 7, negative 7. So my range value becomes an inequality every time with parabolas that are in this form. Quadratics, they will always have your range as an inequality, and your domain will always be real numbers, every single time. Now that we've gone over graphing these with a couple different strategies, how to find the vertex, whether or not it's going to be positive, again, we look at that a value, or if it's going to be negative, if it's a negative a value. I want you to take some time and practice this on your own. So you all should have sheet 4.1. I want you to try both sides, page 5 and page 6. One is going to have you look at graphing these, and the other one's going to have you looking at calculating your vertex, your axis of symmetry, your y-intercept, and your domain and range. Please feel free to re-watch this video if you need to, okay? Don't say I didn't know because I just went over an example for you, okay? If you need help, come see me. I'm available in the mornings and afternoons. Good luck!